Good morning and happy Wednesday. Today's lesson should be pretty short because the people that turned in the homework did fantastic. So I was just going to put up the homework answers so y'all can kind of check and see how you did. The only thing I'm going to suggest that you should kind of work on today is the rounding. Some of you totally got the answers right, but just rounded incorrectly. We want to make sure we're rounding sides to the hundredths, so that's 2 places, and then angles to the nearest degree. Okay, that's in the directions there, but if you notice, everything I did in pink here is finding a side, and then everything I did in blue is finding an angle. But like I said, based on the data that I got, you guys you're catching on very well. So today we're going to do the same kind of thing, but we're going to do application problems. We've already done these, so hopefully it doesn't seem too, foreign or off from things that we've done before. The only thing is we haven't done angle 1, so I was going to do 1 and 6 with you and then have you do 2, 3, 4, and 5 for your practice, okay? So this will, let me just go ahead and say, it'll be a mixture of finding sides and finding angles, just like the practice was yesterday. Okay, now that we kind of know how to do it all. All right, so a penny dropped from the top of the Leaning Tower of Pisa falls to a point 14 feet from its base. So there's one of my keywords, base. So I'm going to put 14 feet here. If the tower is 182 feet, now, here's why I picked to do this problem. It's because a lot of students are going to put 182 here. But see, this one is a little weird because it's the Leaning Tower of Pisa. If anybody's actually been there, it leans. Now, not this drastically, but it does. So 182 feet's actually going to go here. Okay, because it's like a, something that's leaning. Now, that is kind of a little ridiculously leaning. As is my picture, but it does lean nonetheless. Okay, so it says, at what angle does it lean at the ground? So here's our Leaning Tower of Pisa, here is the ground, and so where those two come together is the angle we're looking for. So this is our theta. Okay, does that kind of make sense? And so now we just work it like we did the problems yesterday. Okay, so according to our theta, this is our hypotenuse, and this is our adjacent, so that means we're going to do cosine. And remember, after the trig function goes the angle, which we do not know, and then cosine goes adjacent, and then hypotenuse. And then to type that in, I'm just going to use my handheld, but we're going to hit second cosine, and then 14 divided by 182. These are so much easier. We don't have to think about multiplying or dividing. We just type it right in. And we get that theta is approximately, and we're going to continue to use the rule, round angles to the nearest degree and sides to the nearest hundredth. So this is 85.5 degrees, and so when we round that, the 5 is going to round it up, so 86 degrees. Okay, so that's how we'll do that one. So let's look at number 2. It's talking about Beyonce. You're welcome, I made that one up. And it's talking about the angle, if she goes down a slide and knocks you over, what is the angle that the slide makes with the floor? So it's going to be kind of similar to the previous one where the angle is, but make sure, a slide is leaning, so make sure you are clear of that. Number 3, it's asking for the direct distance. Remember, we talked about that before. I'm not going to say it right now because I want you to think it through, but that is like a specific location on the triangle. If you don't remember, you can go back to I can't remember the date, but we definitely talked about it in a previous video. Okay, so that one you're looking for a side as opposed to an angle. Number 4 says a 90-foot escalator rises. Okay, so let's be careful here because an escalator, in the mall, it kind of goes like this, right? So you can draw your triangle like that if you, oh gosh, sorry, my hand slipped. You can draw it like that if you want, or you can just continue to leave it like this. But no, this is the escalator, right? When it says vertically, we're talking about that distance. Okay, and then it's talking about the angle, so you are looking for an angle there. Number 5 talks about a guy wire, which is just a thick wire that holds a pole. So we're going to have a pole like this, and then we'll have the wire like this. So just FYI. And it says how far is the base, there's a keyword, from the base of the pole. So you're looking for a side there. Okay, so make sure you're looking for angles. I'll circle them in pink. That's not purple. So all of these you're looking for angles, and then the other 2 you're looking for sides. Okay, and now let's look at number 6. It says a plane flying at an altitude of 35,000 feet. Okay, so let's first start by altitude. Remember, is another word for height. So it goes here. The direct distance, I'm about to give it away, but that's okay. The direct distance between the plane and the runway is 100,000 feet. So remember, direct distance is hypotenuse. And it says, what angle of descent must the pilot fly? So y'all remember, angle of descent is like angle of depression, okay? So let me draw this in. Angle of depression, the angle at which the plane will decrease or descend or go back down to the runway, is that. But does that really help us in this problem if it's outside the triangle? The answer is no. So we're going to put theta right here, because do you remember about alternate interior angles? This angle here is congruent to that angle there. Okay, so again, angle of elevation and depression kind of end up at the same place every time, even though they don't really start in the same place. Okay, so let's label these guys. So according to the angle we're looking for, this is O and this is H, so that's sine theta equals, and then we go O over H. And then we're going to type in second sine, and then 3,500 divided by 100,000. Okay. I actually could have reduced that fraction if I wanted to, but that's okay. And then when I round, I get 20 degrees. Approximately. It was 20.4, and so that 4 does not make it round up. Okay, so your job is to try 2 through 5. See if you guys can try those. We'll practice more tomorrow. As you saw, there were more below, but we'll practice more of them tomorrow. And then honestly, we're going to just kind of wrap it up, put it all together with special right triangles, and then we're going to have a test over special right and the trig, and then we'll be done with this unit. Also, if you have questions about your grade, I'm happy to answer those. It's just taken me a little bit of time to calculate, like, have you done 5 assignments, and then did you score an 85% or higher on the quizzes, so you can earn your points, but I'm happy to do it. So if you need to ask me questions, feel free to ask. I'm not putting any grades in the grade book because we're not really allowed to, so I'm just kind of keeping up with it on a hard copy here at my desk at home. So just let me know. I'm happy to help. Miss you guys.